Hello everyone, welcome back to MGF1106. So in this video, we continue discussing the truth table for the last two compound statement, the if and then statement and if and only if statement. Okay, so let's get started. Section 3.3. Okay. Truth table for conditional and biconditional statement. Okay. The conditional statement, we call that if and then statement. So let's talk about that one first. Conditional statement, which is if and then statement. Okay. Again, we will examine a simple statement. So given P and Q. Okay. Statement. Then if and then statement will be symbolized as P imply Q. So this is the symbolic statement for conditional statement we already learned in the previous video. Now we're gonna go ahead and create the table for that. So I'm gonna just draw the table because this should be a simple one. Well, I'm gonna go ahead and get the table. We have it here. So we're gonna put P and Q here. Okay, so this is P, Q, and this is P imply Q. Okay, so we have only two simple statements, so we will have four different arrangements. So we will have true true, true false, false true, and false false. All right, now in order to get the true false for this column right over here, again I have an example, and if you memorize this example, then you don't need to memorize the whole table. So the example goes like this. A promise that if you get A in class, then I'll buy you a watch. Okay. So P is right over here. So P is the if statement over there. And the if statement, we call that the antecedent statement. So P over here. So P. So this is antecedent statement. And the statement down here, we call that consequent statement. Consequent statement. Okay. Okay. So if you get A in class, then I'll buy you a watch. This is a promise. Okay. So look, in the first case, we have true true. So if you get A in class, and this is also that this is you, I buy you a watch. So both of them are true. So it means that right over here will be true. If you get A in class, and for the this statement is wrong, and I don't buy you a watch. So this should be false because the consequence statement is also important. That you get A. This is a promise. A promise. If you get A in class, then then I buy you a watch. So you get A, but I don't buy it. So the promise is broken. So it will be false. Um, so this the first time the antecedent is false. So if you don't get A, but you still get a watch, you still get a watch. So this somewhere somehow you don't get A, but you still get a watch. So this true right over here, right? You still get a watch. So this one would be true because even though you don't get A, but I mean you still get a watch. And if you don't get A in class, you don't. I don't buy you a watch. So this is for and for. Okay, it's for and for. If you don't get A, you don't get a watch. Of course, so this is should be true. Okay, okay, because if you don't get A, so what is the point? You know, then you don't get a watch. That's this logical, right? If you don't get A, you don't get a watch. So this one, the conditional statement over here should be true. Okay, so we're gonna have true, for, true, true. Okay, now let's jump to the example right away. Example number 1. Okay, so I have the. Let's see, we can start with something simple first. How about this? I'm gonna go ahead and pick this one first. Okay, construct true table for. Okay, so I have the compile statement like this. P union Q, P or Q, and negating P, and everything over here imply Q. Okay, so this is a complicated compile statement right here. So let's see how we do this. Okay, first of all, we need to get the table. Okay. So again, we have only two simple statement P and Q here. So we have only for arrangement. So we have P here, Q here. Then we have a negate of P. Okay. Then we will have I don't know how I'm gonna make it. And we have inside the bracket. So I'm gonna put like this. Okay. Inside the bracket. Then finally we have inside the bracket imply Q. Okay, so inside the bracket imply Q. Okay, so totally we have oops, I don't know, we missed anything. Oh, we forgot this. We forgot a P. We forgot P. P or Q also. So I'm gonna erase this. We don't want to miss anything new here. So we will have um, P or Q. Then we have negate of P. Okay. Then we have inside the bracket. Okay, which is the end right here. Okay. All right. So let's put it in. So I will have chew, for chew. Okay. For chew and for false. Okay, so let's do the or. So the example is the problem is to argue if you either have bachelor degree or experience. So this two will be true. So this is also be true because he has experience, he has bachelor degree, also should be true. He doesn't have experience or bachelor degree, should be false. Okay. Now we want to negate P, so P is this. Negate that with you false, true, true. Okay. Then we're gonna do and is the promise if you promise that you deliver TV and laptop at weekend, right? Both of them. So true it to be true. True false, so will be fail. So we fail because he did not deliver laptop. He did not deliver TV. So we fail. If he doesn't be, so this was also F false because he does not deliver TV, no laptop. So we false. Okay. Uh, 2, 4, 4. I just want to make sure that I do it good. Oh, let me see. 2. So this one would be N, right? 2, 4. 2, 4 will be 4. Oh, I'm sorry. I don't know why. Look at this one. It should be this. You go with this. So this should be this. Go with this. So this is a 2, 4. 2, 4, 2, 4. 2, 4 will be 4. 2, 4 will be 4. 2, 2 will be 2. 4, 2 will be 4. So 4, 4, 2, 4. Yeah, it makes sense because this one or this one. This one or negating P. Okay. Oh, not or and. This or this and this. So he failed deliver laptop right here. He failed deliver laptop. Deliver both. He failed to deliver TV. Okay. And now we're gonna have this and Q. Okay. So this and Q. So the example that if you pass the course, you get about your watch. Okay, so look like that F over here, so look like you did not pass the course, but I still get you the watch. So this is still true. Okay, this is also still true. Okay, two will be true, and four also be true. Okay, also be true. Everything true. Okay. So the whole thing is true, and if the whole thing is true, what we have over here? Okay. So if the whole thing is true, we this compound statement, this condition statement over here, we call that tautology. So this is tautology right here. This is tautology because the compound statement over here, the if and then statement is turned out to be true for all of them. So this is tautology. Okay, tautology. Okay, because it's all turned out to be true. Now let's do another example here. Example 2. Okay. So in this example, let's say I give you the sentence statement, then you convert it to symbolic statement. So then this sentence statement over here, there are three. This compound statement here, there's three simple statements. Okay, so I have something like this. Okay, if you drink coffee, okay, in the morning, okay, comma. Try to be careful with the comma. Then you will not be sluggish. Sluggish. Okay, and you will have a great day. Okay. So the comma is right over here. So this look like the whole thing down here. This part right here, this is a whole. It's together. It's a whole group. So in order to get the symbolic statement over here, if you drink a coffee, so we need to name the statement. So this P over here, you drink coffee. Q is you you will be sluggish. Okay, and R over here, you have a great day. Okay, so with this sentence statement, simple statement over here, so let's see, we can get the by condition. Not by condition, just condition statement. So we have, if you drink a coffee, so I will have P imply, then you will not be sluggish, so imply negate of Q and R. There you go. Okay, so let's see, we can put it on the truth table. Okay, so we have three simple statement over here. It means that we will have 8 arrangement. So we will have over here, we will have P, Q, R. Okay, negate of Q. Okay, then negate of Q and R. Then finally we'll have the whole compound statement. I call that A. So this is A right here. Okay. Okay, so we have 3 of them. Okay, 3 of them. So we have true, true, for, true, for, true, for, true, true, for, true, for, true, and for. Okay. Then we negate Q. So this Q here, so we just negate Q. You F, 2, 4, 2, 4, 2, 2. Okay. Now we're gonna do N between this column and this column over here. So N is a promise to deliver a TV and laptop. So it cannot deliver TV right here. So it's gonna end with F. Cannot deliver both. So you're gonna end up with F. This is 2. This is also F. It's also F. So this is also F2, and over here is also F. So we have FF, T2, FFF. Okay. And over here we will have column for A. A is P implied. P imply this. So 2 imply F. So we just give you F because F over here is the consequence statement. You did not get a watch. Okay, you pass over, so this over here will be F. And this is also F. 2 will be 2. F will be 2. 2 F will be F. F will be 2. F2 will be 2. Okay, and FF will be 2. Okay, so you this is implied, right? So you did not get A, you did not get a watch, so this is true. You did not get A, so you did not get A, so you still get the watch. This is also true. You don't get A, so you get A, but you don't get a watch, so it will be 4, 2, 2, 4, 4. Okay, good. That's example 2. Let's see if we can do another one. Okay, let's see if we can find another one to do here. Oh, well, how about this right here? Okay, how about this? P. Okay, example number 3. I don't know if I have enough space for this or not. No, I don't have enough space right here. So example 1, example 2. Let's try to do another example. So I don't have it anymore. Yeah. I don't have space here, so I have to jump to another one. Let me see. I can put example 3 right here. Okay. So in this example 3, I want you to construct the table like this. Show table. Okay. Let's see. P. Okay. P and Q imply P or R. There you go. Let's see we can set up the table for this. It's all of this not hard, right? Just a step. That's all. Okay. So we have over here P Q R. I don't know. We have enough space, or this color is not good. So I will have P Q R. Okay, then we have what? P intersect Q. P intersect Q. Then a P union R. P union R. Then finally we have that statement A. So I'm going to call this statement A right here. Compound statement A. So that's statement A right here. Okay. Alright. So again we have 3 of them, so we have 8 arrangement. So you have chew, then you have chew for, chew, chew for, chew, chew for, chew for, chew. Then you have for. Okay. So we're gonna do N. Okay, for P and Q. And for P and Q, so both laptop and TV lab is deliver. So this true. It's true for. Okay. Then we do or P and R. So with two for two. This is with two too. This is two. Okay. This is P and R. So this is also two. This two. For two. For all two except for F and F at the bottom. Okay. And now we're gonna do conditional. So you pass the class, promise you pass the class, you get a watch. So it's true. You pass and you get a watch too. This is still true. You don't pass, but you still get a watch. So this is also true. It's also true. It's also true. You know what else is also true? It's also true. It's also true. So all of this is true. So look like this. We have tautology also. What we put tautology. So here we also have tautology here. Okay. There you go. Good. Now let's talk about the suitable for the biconditional statement. So number 2. Second Roman. Biconditional statement, which is if and only if statement. Okay, so given P and Q statement. Okay, then by condition statement will be P go both direction, Q if and only if, P if and only if Q. And from here we can go ahead and create the table. Okay. So we will have P here, Q here, and P equivalent to Q. Okay. Again, we have only two statements, two simple statements. So we have true, 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 for true, and for. So P and Q equivalent. So true and true means this is true. True and false is not equivalent, so it's false. False and true is not equivalent, so it's false. False is equivalent could be true. So this table over here is the true table. It's very easy to memorize. We don't have the exam because as long as you think that the symbol over here means equivalent, then you can get it easily. Okay. Well, later in the next section we will talk about equivalent statement. Okay, they use a different symbol, but just assume that this is equivalent. Okay, for you to memorize, because if you just think in your mind this is equivalent, then you can get the table correctly. This is not equivalent symbol. Okay, it's not. But if you think this is equivalent symbol, then it's just a trick. It's just a trick for you to memorize. Okay, because we don't have the example in the previous statement. We have the example for you to memorize, but this one we don't have it. So just treat this as equivalent, then you can get true and false for this column easily. Okay. Now let's do the first example right away right here. So over here, I will have something like this. Construct true table for, okay, P or Q, if and only if negate of P imply Q. All right. So let's see how we do this. Okay. It's not really that hard, guys. Very easy. So again, we're gonna have here P. Oops, this cannot see anything. So let's use this one. P Q. This is negated of P. This is P or Q. This is negative of P imply Q. And finally, we have the whole thing. Okay. So we have a whole thing down here. All right. Let's put it in. True, 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 for, true, for. Negated of P will be for, true, true. Union of this, so true will be true, for will be true, for and true will be true. Because it satisfies only one condition. For it does not satisfy any condition, so it will be for. Now then we're gonna this one right here imply this one. Then you think about if you the example that if you pass the course with A, then you get a watch. This imply to this if you this is for, you didn't pass, you still get a watch. So that the consequent statement is more important, so it could be true. Okay, this is also true. Oh, hold on, did I get it correctly? Okay, this implies this. I'm sorry. Negating of P imply Q. So 4 to 2, 4 to 2 will be 2, yeah. False to 4. You don't pass the code, you don't get the watch, so will be 2. 2 to 2 will be 2. And 2 to 4 will be 4. Okay, right? So you get this, so you don't pass, you pass the course, but you don't get the watch, so it will be 4, because this is a consequent. You don't pass the course, you don't get it. 2, yeah, you don't pass the course, but you still get it, so this is true. Yep. And now let's talk about A. So equivalent. Equivalent. It's not equivalent, okay? It's not equivalent, but if you treat it as equivalent, you can get it correctly. So this one to this one, this one to this one, this is true, right? Because this, if and only this is or if and only this, true, true will be true, 4 will be true. Okay. Okay, so this is tautology again. Tautology. Because all of them is true. So this is tautology. Okay. Tautology. There you go. Yeah, very easy, guys. Very easy. It's not hard. Then let me see. Next we can do another one. Um, how about this one right here? This is pretty complicated right here. So let's do number 32 in the text as the second example. So we want to construct a truth table for this. We have 3 compound statement, 3 simple statement. N. This is Q or negate P, and everything over here is if and only if with negating Q. Okay, again I'm going to call this A. Symbolic statement A. Alright, let's put it in, guys. Let's put it in. So we have 3 of those, so we have 8 arrangement. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so it's enough. So I'm gonna put over here. P, Q, R. Negate of P, negate of Q. Q or negate of P. Okay. Then we will have the bracket statement. Then finally we have a statement. Here you go. The bracket statement over here is the O, is the N. Okay, so let's see. Okay. So we're gonna have chew, 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 chew for, chew for, chew, for, chew, chew, chew for, chew for, chew, and for. Okay. Now we're gonna go ahead and negate P. So it will be for Okay, for, chew, for, chew, negate Q will be for, chew, for, chew, for, chew. Okay, negate this. Now we do the union, okay, between Q and negating P, so between these two columns right here. So true form will be true. Okay, true form will be true because they just need to satisfy one of the requirement. Same thing will be true, and this one does not satisfy any requirements. So will be for, will be true, for, true, true, true. All right, and now we do the bracket. With this, so n means satisfy both conditions. True with true, laptop and TV, laptop. Will be for no TV but laptop has laptop, has TV but no laptop. True with true, no TV, no laptop. Will be for the promise broken. There will be for also, and it will be true, and this one will be for because this no TV. This is laptop but no TV. Now we're gonna do this bracket over here with negated of this. So again, let's treat this as equivalent even though it's not. So negate of Q for 4 equivalent to 2 will be 4. 4 equivalent to 4 will be 2. 4 equivalent to 2 will be 4. 2 equivalent to 4 will be 4. 2 equivalent to 4 will be 4. 4 equivalent to 4 will be 2. 2 equivalent to 2 will be 2. 2 equivalent to 4 will be 4. So the final answer is this column, right? Okay. All right. Again, if you don't get it, why I get 2 and 4, you can ask me any question. Just send me a message to Canvas inbox. But if you memorize the formula I give you, the example I give you, then you can do anything, you can create any true table. I can tell you that. Okay. All right. So I guess I'm gonna stop right over here because I think this is complicated enough. Okay. Yeah, it's two. I think 2 examples is good. You have to practice a lot in the my MATLAB homework. To give you a lot of chance to practice. If not, you have to just go ahead and get the book, the textbook, and practice on the problem. If you have any question, please let me know. I'll see you next time.